a technique called the mask technique that you choose to only manipulate a certain bit except for the whole register. And so if we have a chance, we will see. I will see if I can cover that topic. But here, because this is a rather easy application, there's no much like bit that we need to concern that is controlling either thing. So here we just directly override the value that was in port B with the new value we set to control it to display a 2. Okay, so down there we also having a this is for controlling the port B. So you can see how the MSB 4-bit are actually keep 0 because that 4-bit is actually reserved for other purpose. And this is basically your PT3, and this is your PT0. So we want to display at the very, in this case, it's asking for the far left, which is your MSB. So we learned that the MSB of the displays for the 7-second display is actually controlled by PTP0. So we put a 0 here to kind of like turn off the PTP port. And by doing that, the 7-second display will be able to connect it to ground to form a closed circuit, to be a complete circuit, and it will start to display something. Okay, and down here we have another BRA and go to over. So this is just basically forming an infinite loop to kind of like keep displaying that number.
Samson, when we branch over and keep this loop, I don't see any.
Again, sorry?
When we just branch over, like when we just do this looping, I feel like personally, like it's making it again and again to display that number that we want to see. Beyond the imagination of human eye, like the timing is so fast, it just look like it's like stable and like a fixed number is just showing. But I feel like that number is literally like on and off within like 13 millions of microseconds.
Okay, I think in this case, let me think about it. Because the thing I just mentioned, like about the human eye illusion part, is for displaying 4 different number. Like they all turn on in a different time, but because they're so close, we feel like the 4 of them are all turned on. But in this case, when we are looping through, it is so I will say the loop over here, if your purpose is only displaying a 2, is kind of redundant here. But the reason why it's still introduced over here is that it keeping with its clock frequency is keep checking that if this value is going to change or not. So in our case, in this simple case, the value over here is fixed into 2. But let's say, what if we have actually kind of like a method, or say a input that is going to be changing this value to make the display changing, like displaying different number. In that case, we do need this loop to kind of like keep checking what is the current condition right now, and it will reflect that latest update into the display once ever it check it, right? So we are actually going to take a look. We're actually going to have a look on like why we're having this loop over here, loop structure here, in the second section. So at that point, I think you will have a better idea of why this is happening. And even though it's like looping the same the same kind of code, but there's a reason why I believe it needs to be introduced over here. Okay, so at the second section, we'll have a better look on why the loop exists over here. Okay, so that's pretty much for the first one. Very easy, just displaying a 2 over here. So just always keep in mind, like you need to configure all of the pin. You need to use as output into output first. And then when you configuring your 7-second display, you need to pick which one is going to be on, and you need to pick, that will be achieved by configuring your PTP. And then you need to decide what number you need to display, which is going to be determined by putting some number into your port B. Okay, So let's take a requirement here. So the requirement code over here, you can see, we kind of like ignoring some part, about the ORG and the LDS part. That it's kind of like assume that you already have it. And so the first line is LDAA-FF. So it's the same strategy here. We are turning our DDRB and DDRP, the port B and PTP, into output mode. So we basically define FF, and then you move that number, move that FF to replace the whatever value was in the two register in port B, in DDRB and DDRP. Okay, and then we see there's an LDAA0 over here. So, and then you put that into DDRH. So this is basically you configure your port H, your PTH, into input mode. Okay, so therefore you choose a 0. So for just a recap, remember that at the beginning of the next section, I actually showed you guys there's a read switches just below the 7-segment display, right? So those are the circuit connected to PTH. So right now, if you want to use those switches as your input of your code, you need to configure the port H into input mode. So that's basically what it does over here. It put a 0 into accumulator A, and then store that 0 into DDRH to configure your port H, PTH, into input mode. Okay, so everything above here is just the port configuration. Config. Now everything below is start doing with the like you can see as a main program, like where all the logics and input and output take place. So first we take a look at LDAA, which is right now still 0. Wait, let me take a look. LDAA from PTH. A load from PTH. Okay, so here, remember that we configure PTH right now is as input. The red. So what we are doing over here is we're loading the current value from the PTH into accumulator A, right? So this line over here, as a whole, you can see it as read input. Okay, and then we storing the value we have just read into port B to control. We all know that port B is going to be control which number is displayed on the 7-segment, right? So this 2-step as all is like one for reading